Hello, ladies and gentlemen, boys and girls. My name is Chris Keller, and in collaboration with the rest of my team, we will be presenting on the Trebuchet Project and how we built our Trebuchet. The team includes myself, Josh Sanders, Luke Busch, and Jack Welch. Let's get started.
When our group met for the first time, our first question was what was the difference between a trebuchet and a catapult? The definition of a trebuchet is a medieval siege engine consisting of a large pivoting arm heavily weighted on one end. A catapult is defined as a device in which accumulated tension is suddenly released to hurl an object at some distance.
The goals, restrictions, and specifications. The goals as a group was to build a functioning trebuchet that can release a marble using a launching arm system and a counterweight. The goal as a class was to create the most efficient trebuchet according to the equation E is for efficiency, so E equals the mass of marble times the max range divided by the mass of counterweight times the vertical drop. The specifications of it is it must have had to fit in a 12 by 12 inch box, and 25% of it had to either be used as a laser cut or 3D printed. The required math. There was 3 equations that we were required to have math-wise. The first one is converts potential energy to kinetic energy, which is mass times gravity times height of the counterweight converts into 1/2 times the mass times the velocity squared of the projectile. The second equation is the range of projectile with the initial velocity and angle. R equals range, so the range equals 2 velocity squared sine of angle, cosine of angle, all divided by gravity. The third equation was the maximum theoretical range. R equals max, so R max equals 2 times the mass of the counterweight divided by the mass of the projectile times the height altogether.
We initially used computer simulations by using the online website virtualtrebuchet.com with the program Virtual Trebuchet 2.0. We tried several different simulation programs, but that one seemed to work the best. We took optimum measures of lengths of parts of a trebuchet from offline, and then we converted them to meters and into a size that would work with our size restrictions. We then took the mass of the marble that we would be shooting so that we could accurately display how the trebuchet would work.
For our design, we used a simple trebuchet. We have a long arm in the center, a base, as well as a triangle for the 2 supports for the arm. Our base was made out of a 3D print, and the arms are made out of PVC. The weights were provided by Mr. McHugh, and the pouch was made out of cloth. When making the trebuchet, we came into some problems with the lengths of arms and such. So for the pouch, we had it too small, so we had to increase the size of the pouch and also change the shape from a square to a large diamond. For the long arm length, we had to shrink it down so that it would get more torque when it would swing. And the short arm length, we had to shorten that as well, because when the weights would drop, it would smack the base instead of doing the full swing underneath. So when we shortened that, it was able to let the weights swing all the way through. And we also had to change how the counterweights were attached to the short arm. We did have it in a basket in the design, but when making the trebuchet, we realized it would be better just to attach the weights straight on to.
When reviewing the efficiency of our design versus the simulation, we realized that the efficiency of our design was 0.232 and the efficiency of our simulation was 0.481. This change in efficiency could be due to the movement issues we had when building our trebuchet.
6, 3, 2, 1.
The second part of our testing consisted of the mechanics and operation of the trebuchet itself. Some operation issues we faced during building our trebuchet was that we realized the hole cut out for the trebuchet throwing arm was too big than the other PVC pipe that held it together, resulting in a wobbly effect that threw both the projectile and the throwing arm out of balance every time. Another problem we faced was the pouch. In our first test, we realized that the pouch had too much duct tape, resulting in the marble being stuck in the pouch and never releasing from the pouch. Test 2. Not only did we look at operation issues when building the trebuchet, but we also looked at some operation achievements as well. One of these operation achievements was the ability to build a trebuchet that actually launched the marble. Another operation achievement was the ability to not only build a trebuchet, but build a trebuchet that was able to hold its weight and not break throughout the entire test. After all the testing was complete, as a group, we all sat down and talked about what we could do better if we were to build the trebuchet again. And we decided if we were to build the trebuchet again, we would make sure all the connections, including the throwing arm, the legs, the counterweight, and the pouch itself, all had tighter connections. These tighter connections would allow the movement amongst the whole trebuchet to be easier and more fluent. Also, it would allow the projectile to be straight rather than unbalanced, like our trebuchet during the testing.
3, 2, 1. Yeah.